Hello. Fine.
Good afternoon to everyone present here. We'll be starting our second session now. This session will be conducted by Dr. Lal Sarkar. Dr. Lal Sarkar is an associate professor and head of Department of Computer Science and Engineering of Techno College of Engineering, Agartala. He received his MTech in Computer Science and Engineering from Biju Patnaik University of Technology, Orissa, and a Doctor of Philosophy in Computer Science and Engineering from Tripura University. He has completed his postdoctoral research from National Taipei University of Business, Taiwan. His research interests include software defined networks, Internet of Things, recommendation systems, artificial intelligence, and health informatics. He has published more than 70 research papers in different referred international journals, conferences, and book chapters. Dr. Sarkar has been awarded the Best Paper Award by several renowned international conferences. He was awarded the Best Reviewer by the Digital Communication Network Elsevier. He has worked as a security administrator at the NIC Tripura State Center of Ministry of Electronics and Information Technology of the Government of India. He has been invited keynote speaker and panelist in multiple global conferences and panel discussions. He serves in various capacities in multiple global conferences such as MICA 2022, ICACIE 2022, IEEE ANTS, etc., in domains of communications, networking, and machine intelligence. He has also received numerous prestigious travel grants to attend conferences, workshops, and meetings around the world. He is currently serving as a review editor in Frontiers in the Internet of Things, Lausanne, Switzerland, and collaborate with an expert research community in IoT services and applications. Dr. Sarkar is currently serving as an editor of International Journal of Advanced Intelligence Paradigms, India Science, International Journal of Computational Systems Engineering, India Science, and section editor of Smart Tourism, Asia Pacific Academy of Science. Dr. Sarkar is also serving as a co-director of IEEE MMTC Communication Frontier. We are glad to have sir with us today.
Thank you for your wonderful introduction. First of all, thank you entire Techno Group and organizing committee, principals sir, directors sir, allowing me to come here and speech. So today I'm going to discuss some of the basic concepts that we are working from last few years. That so my title of the topic is modern tools and their applications in healthcare. So nowadays we have seen that healthcare is one of the most important part for our day-to-day life. So that's why we can't ignore each and every points of healthcare. So that's why we are really motivating to work on. So my outline is I throughout my presentation I'm going to cover healthcare research challenges and some of the research paper and research work and some of the projects that we are working from last few years that I'm going to discuss today. So once again, please confirm sure of that my voice is clear. So am I audible? Everything is fine. So can I continue? Yes, fine. So you can see that there are a lot of research challenges of there in case of Indian hospital concern and hospitals and healthcare concern. You can see the scenario. So we have different types of problems. Suppose if we consider like pharmacy, radiology, and hospital, so and laboratories, we have a lot of question mark. So if we are like in healthcare emergency, immediately there will be a lot of questions that am I target in a particular hospitals, so am I going to treatment particular the best doctors in my state, or the laboratories is good or not, and my entire surgery or whatever it is treatment is covered by insurance or not. So there are a lot of questions are there in our mind. But what is the main problem is that, so recently we are in the era of digital technology, right? So everything we know that we are in the era of digital technology. But the main problem is that, but as well as I need to mention that smart city as well. We are in the era of smart city. But till now we can't say that our medical, the facilities are well enough. So if I tell you that, are you satisfied with the existing systems? 99% people will tell that no, we are not satisfied. But why? Because we are already in the digital era. We are already in the smart city. That means there is a lot of lacuna are there that we need to solve one by one. So that's why you have started research from few years back that in healthcare domain. So fine. So this is the scenario, that a practical scenario. One of the renowned hospitals in India, it is called Delhi AIMS. You can see that 10,000 OPD patients, many die waiting at crowded AIMS. So you can see. So we have survey in Delhi AIMS also. We have seen that more than 50,000 patients are regularly visiting in Delhi AIMS. And this is a scenario out of 50,000 patients. That's or if you see that many patients waiting at crowded AIMS, they may die. So that means there is a real life scenario, a lot of problems will occur. And if you consider like other hospitals, like government hospitals, the scenario is really very difficult, right? So AIMS, this situation is AIMS. So you can consider that our GB hospital and local hospital or hospital in Kolkata, government hospital or Delhi or Mumbai or any state, what are the main condition, right? So there may be a lot of problems are there in case of government or private hospitals. And less than one doctor for 1,000 population in India. That is also one of the main issues here, because you can see that less than one doctor for 1,000 population in India. But if you see that the guideline of WHO, the guideline is totally different. I'm going to show that what is the exact guideline from WHO they have covered, but we are not maintaining those due to the lack of doctors. So that is our real life problem. So how to solve the problem? Because we have a lot of patients per day. Like right now, also maybe any healthcare emergency will come and very difficult to solve, right? So that's why we need to send our patients in a better place so that that can be rescued by a particular team or doctors. So that's why the problem arises. Fine. So we have survey. You can see that poor healthcare kills 16 lakhs in India every year, and that is a fine studies. Poor healthcare kills 16 lakhs in India every year. So that is the data. So we have done a research on that, and we have find this data. And data is really, and we have collected from WHO website. So that is totally valid data. So you can see that more than 16 lakhs in India every year, poor healthcare kills. That means there are a lot of problems are there. And if you consider like other countries as well, you can see there are a lot of other countries I have mentioned, like Brazil, Russia, China, and South Africa, and neighboring Pakistan, Nepal. You can see that their scenario, because India is high populated country and there may be a lot of problems, right? That means death ratio also very high. So that's why the problem arises, right? And also our budget also maybe one of the main concern here. Our financial budget of healthcare, that is also one of the main issues in India. Fine. So I did some survey related to our healthcare. You can see the top causes of death for female. So that is the a lot of causes are there. I have highlighted some of the cause rate, but causing factor. There may be a lot of other factors are also there, but I have highlighted few factors here. So that is the scenario in real life, and you can see that the top causes of death for male as well. So there are a lot of other statistics as well. And this is the advantage of India is majority of people from India is like 25 to 30 age or 19 to 25 age. That means we are in the very young populated India, I can say. So that is the real life scenario. That means a lot of young people are there in India, right? There is no voice. Am I audible? Hello? Clear? I think your mic need to right. My voice is clear? Okay, fine. So that is the population. You can see that there is a fat system, right? There is a fat system in the middle age. You can see the increase of fat in the middle, right? So that means there is a increasing order, right, in the middle only. That means we are in the young populated India, we can say. So that means we can do a lot of things. We can do a lot of research on that. But as I already committed to you that I will discuss about some of the basic tools and their application in healthcare. I'm going to show you some of the basic tools like MiniNet. Why is this? It is so much popular, MiniNet. So what is my objective is I will going to show some of the simulator to you that you can use in your research work today, and after that I will see what we done, okay, what we did throughout the few years. So that I'm going to discuss about here. Fine. So Mininet is a popular open source network emulator used to preliminary for testing and development purposes. I think maximum of you we are thinking about router, but recent the trends is like that. We should think about software defined network, right? So your software can automatically detect all the errors. There may be a controller and switch technologies are there, and it will be automatically resolve those issues. So that means we are telling about the current scenario, current generation. We must use the software defined network, those technologies. And you know, and those devices are very costly, but we can't stop our research work, right? Because we are very we should continue our research work each and every moment, right? We can't stop for devices. So what we can do is, so there are a lot of simulators are there like Mininet. Those type of software we can use. It is open source, right? That's why I'm telling that open source tools are available. So their software give you a feature. You can use the software. You can continue your research. And same manner when devices will be available, you can start your research through devices as well. Fine. So what are the other features of Mininet? I'm not going to discuss about in detail, but some of the overview I'm going to show as I promised already. So this Mininet, give me some seconds so that I will show you for something. Okay, otherwise later I will show that this description. Fine. Another important things, it is called MQTT. So those who are working in healthcare, so we can't rely on simple HTTP framework, right? So it is just like that forwarding your data from one place to another place, and it is called totally unsecure, right? If I use that HTTP or something, because that's why our data need to be passed through a proper channel. That's why you need some MQTT, this type of protocol. Okay, so that means your data should be secure, right? So how your data would be secure? Based on the MQTT technique. But you can't use directly MQTT technique. You need some broker over there. Okay, broker means suppose if I want to use, please, if you silent, then it will be good. Otherwise, you can, sir, please. Otherwise, I feel some disturb, right? So fine. So if it is you that it is MQTT means, suppose you can send your data to the particular channel. That means that channel should be in a secure position, right? So because in healthcare, I can send your data free of cost, right? It is my body, right? Ultimately, everything should be secure, right? So that means if you collect from, if you go suppose any private hospitals also, they can't give you data because data should be secure. So that means you can send your data from through proper channel. So how to send? So through MQTT channel, MQTT broker, you can easily utilize those broker and you can easily send. So there will be a, another important thing that I need to discuss here. This is called, you can see, just, yes, it is called MQTT broker. So HTTP local host, if anyone have internet connectivity, you just type in. Later on I will show after my presentation, otherwise maybe I'll divert it from this. So that's why there is a HTTP local host 1083. Some protocols are there. MQTT, if you have firewall, suppose I am thinking about, a GB hospital, you can't send your data through the server. There may be one firewall will be there. That firewall restricts, and they will check your data is valid or not. If any malicious data will come, immediately they will they'll give you some warning or something like that. So that's why there will be a we need to allow those type of port. So this port is 18083. So that means it is MQTT port that we need to allow, right? Once you allow, that means you have created your secure channel through firewall. That means your server is connected. Now you can send easily your data through proper channel. So that is the overall objective of MQTT protocol. I think it is very, very clear. I will show some demonstration. I will show after my presentation. Fine. So, and we are also in the era of, you can see that robotic surgery right now. So there is no need of doctor, right? So doctors, there is no need of doctors. Now in India also, in Chennai, already that is developed like robotic surgery, some laparoscopy surgery. The cost is, you can see, I have also highlighted here about robotic surgery. Just a second, you can see the robotic surgery is similar to a laparoscopic surgery, right? So it can be performed through smaller cuts than open surgery, right? So this type of techniques already developed. Okay, so we need to think further, right? What we can do, what we can add more, so that will be like everything will be customized in proper way. Okay, so what algorithm we are using in industry level, it is totally different. That's why customization is very important, right? So that's why it should be customization, then it comes to a methodology. So there may be a trade-off between methodology and industrial use, right? So that's why we need to use in proper way. Fine. So I think this part I have already covered, and this, yes. So there is another tool that is very important tool. It is called oki.com. So that Oki, I have already given you that link. Suppose you are facing your college or your university. Suppose you have lack of funding, right? So you can't stop your research work. So what you can do is you can work through Woki.com. They will give you that MQTT, HTTP, NTP, a lot of other features to you. And they have VS Code facility also there. You can easily utilize those softwares. And believe me, they are also giving you Raspberry Pi support. They are also giving you Arduino board support. Those who are from electronics background, you can easily enjoy those softwares. And it is totally free of cost, something like that. So that's why it is very important to utilize those softwares. Fine. So up to this, some of you software I have discussed. So I will going to discuss about further. So what is the next? So one of our paper that is recently accepted in ISC Bangalore. This is called Saha, and it is one of the throughout 1 year we have done our code and simulator. After that we got the result. This is called an SDN enabled fog architecture for healthcare application. That means I already discussed in my class also that what is the file, not going about very basic, right? So I think everyone knows about that fog architecture. Fine. So that paper has been already accepted in International Conference on Distributed Computing and Networking, which is right wonderful conference in worldwide. It is called 23 edition, right? So if your conference has more than 20 or 23 edition, that means it is really a good. So that's why I'm telling. So thank God our paper has been accepted recently. Fine. So what is exactly meaning of Saha? You can see that we know about that Internet of Things is a fast growing network for interconnected devices, because you have a lot of devices are there. All devices should be connected to each other, right? So now we are here. We need your data from your home. Any patient. So how to collect those data? We have a sensor. Sensor can send to us. Then we can send those data to the particular hospital, right? So these are the advantage of smart city, right? So that's why that Internet of Things concepts came in the market. And we also use suppose some of the data, some of the basic things already I have discussed, like a software-defined network. Those concepts we have used here. And after that, you can see we are trying to identify the patient's critical. Suppose now we are in an emergency state. Maybe you are also feeling very bad. Maybe you are not in an emergency. There are two types. One is emergency, one is non-emergency, right? So if you are in emergency, that means there need to be a special care, right? So that's why we need to check your critical index, and that will give you what is the criticality of your body. If your criticality exceeds the threshold, that means you are in a very difficult situation. For an example, I am telling the blood pressure normal range is 120, suppose 130. For an example, suddenly suppose it fluctuate up to 180. That means you are in a very critical situation. Anytime anything, maybe stroke arise. So what we can do is we need to give you a special care. So right there, our system automatically check based on some critically indexed technology. So that techniques we have used here. Fine. So that's why we have divided our queries. Two types of queries. One is strict queries, another is what? Flexible queries. Strict query means your data is, you are in very emergency situation. We need to send your data through very critical, like ever, right? And another is flexible. That means there is no need for any emergency, just normal patient, something like that. So like that way, we have divided these two queries. After that, I will not discuss about related work part. Otherwise, you may be bored. And I will also skip some, board mathematics here. In my paper, a lot of mathematics are there. I'll just skip here. Otherwise, you'll may be bored. Fine. So with that strict and flexible queries, and we have sent those data as a packet, because in computer science, we know that you can't send directly your data. It's based on some frame or packet, something like that. So what we can do is, you can see that, I think this is the overall framework that we have designed. So we have, suppose a lot of patients are there, and we'll identify what type of query it is, whether it is a strict query or whether it is a flexible query. If it is a strict query, then we can utilize the edge devices. So what are the edge devices? That means my mobile device can be considered as a edge device, mobile device only. What is that advantage? Because for fast communication, that means if I send those data to the cloud when I'm in emergency, that means there will be a very difficult situation. The cloud is so far from me. That's why it is very difficult, right? So we need emergency data to send. That's why there is an edge device. We can consider those edge device whenever you are in emergency. Locally you process your data, right? Then if any firewall is there, if it is a flexible query, you can see that the flexible queries data through firewall, it directly goes to your SDN controller. Then SDN controller automatically checks. I think I will not discuss about that SDN part here. This is very basic. After that, accordingly, there will be a local medical team. We have considered two medical teams. One is local and one is global. So what is the concept between local and global? Suppose right now we are in Suppose we are in Maheshkala, right? We are in Techno College of Engineering. Maybe in local medical team can be considered as a primary health center, right? So primary health center people, if we connected with them, we can get all the data. Particular time, what type of doctor, suppose which doctor is available, who is available right now, or there is MD doctor is sufficient or not. A lot of data we can collect, right? So that is the input from the local medical team, and global medical team you can consider as ILS hospital or GB hospital, right? Or any standard hospital. So from there you can collect data. Particular time this surgery will possible or not, or particular time this particular doctors is possible or not. So we are interconnected with them also. So we will connect their data so that accordingly our system can process. They can send you in a proper place. So that's why that is the concept. And overall we send those data to the cloud platform to identify, like monitoring the process in proper way, right? So that is the overall objective. Fine. So I already discussed about some of the technology that we have used. So we have used Ubuntu 24.4 LTS, and obviously that your RAM should be minimum, right, 16 GB RAM. Otherwise system will collapse, right? Because we are thinking about lot of data set, more than 64 GB data we are working on. So that's why it is very difficult to send. So that's why RAM should be minimum 16 GB. Oh, there is no maximum limit, right? So that's why it is minimum 16 GB. And obviously we have used MongoDB. Why? Because we need unstructured data, right? Because this traditional MySQL you can't work. Like MongoDB is required because we are thinking about unstructured data. Fine. So already I have highlighted EMQX broker because I already told you what is the role of EMQX broker, right? That tool. So we have used that tool here also. After that, we have compared our algorithm in the some of the baseline technique you can see, and we have seen that our Saha outperforms respect to other baseline algorithm, and we got the better results of this algorithm, right? So we got the better results. I think that will be a that some of the problem we have solved. How to send you during medical emergency from one place to another place, right? But there may be a lot of problems. I will discuss of you what are the different disadvantages of this paper. Fine. So another paper that is a series of paper we have prepared, that is called iHealth. iHealth means SDN based fog architecture for intelligent healthcare in IoT application. So that is this just extension of Saha paper, right? Just extension of Saha paper. So that Saha paper, iHealth paper already accepted in IEEE ACM transaction on computational biology and bioinformatics. And you also know that to get acceptance from transaction is very, very difficult, right? So that's why we received more than, I think, 4 to 5 revision of that paper. After that paper has been accepted. Thank God. So what is the Saha concept here? So you can see in recent year, IoT-based healthcare that I already discussed. I will not going to focus on that. So just I'll come to a point. Okay, successful. Yes. So what we did is, you can see that we collect all the patient data. Suppose you are a patient. Am I audible? Yes. Not streaming, right? Just give me a second. Oh, it need to be shared, right? Okay. I think it is clear now. You check. Huh? It's okay, sure. Fine. So sorry for the disturbance. Fine. So all patients are there. So we can collect all the sensory data from patients. So and we'll process those data to the local data processing unit. That's why there is a chip called LDP that we have utilized here. And after that, we send those data to the SDN controller. And you can see we have used some of the technique. I tell you that is the advanced version of my conference paper. That's why you can see there is a two technique. One is FPS and FRS. So we have used fog probing service and fog ranking service. So fog probing and ranking means, suppose it is some kind of Bluetooth, right? So suppose now how many Bluetooth devices are available from your mobile device? This is called Bluetooth probing. And if you connect with a particular Bluetooth, this is called ranking. After rank, you have connected with a particular devices. So that's why you have utilized fog probing service and fog ranking service, because we are thinking about like large system, right? Your hospital, maybe 4, 5, 6, 7, or maybe more than 20 servers are there, right? So which servers we can connect at a particular moment? That's why we can collect all the utilization value, energy, and everything we can collect. And after that, particular server, maybe it is good for particular time, so particular server we can connect, right? So that's why that is the technology came. So we have used those techniques. I am going very fast, right? So if any problems, so just interrupt me. There is no problem, because so many slides are there, so time is very short. That's why I'm moving very fast. Fine. So that is why the technique is fog ranking service gathers all the quality of service statistical data from FPS. That technique we have utilized here. And after that, we same manner we have also calculated the critical index here, right, based on the criticality of a patient, and we got the better results of that. And same manner like Saha paper, we also our eye health outperforms based on other baseline approaches. Fine. So these are the data delay incurred due to fog node, data weight state, and other states. So I will not discuss about in detail. So that paper already available. You can easily download from internet. Fine. So there is another work that is recently accepted in IEEE Globecom. I think this is called IoT in health sector. I think this is very flagship conference of IEEE. This is wonderful conference. I think this time it is organized by Malaysia. So there one of our paper has been accepted, IEEE Globecom. That is called IoT in health sector, an optical sensor for detection of tuberculosis in suspected patients. So that paper, some of the things we have identified. We have, advantage come with traditional TB diagnostic. What we did is just same manner. We are working with electronics people, right? So because we are not restrict ourselves only the software, right? We need to think about the electronics devices, different sensors, and we got the better results. And you utilized optical sensor. So that is the techniques we have utilized here. So you can see that. So our simulation results, I will not going to discuss all the detail because everything is already there. So that contributed significantly to TB diagnostics. So if you want to diagnose TB patients, we have seen that optical sensor, if utilized, that accuracy is more respect to traditional sensor. This is the overall objective of our paper, overall output of this paper. Fine. So that is fine. Then one of the another research paper that still now we are working. Few of students are here. They are also working with that project. They will be happy, right? So this project is predetermination of adverse effects on patients using machine learning simulation of treatment setup. So what is the problem here? So in 23 April, my father has been expired due to kidney disease, but he admitted in a hospital for like pneumonia disease, right? After that, he died in a kidney disease. So we have found a lot of problems over there. Suppose you are admitted in a one disease and you are died for a different disease. So after that, I just think about, and at that time I really upset. So how to solve this problem in real life manner, right? Because maybe today it's happened with me, maybe after some time it maybe happen with another people, right? So how to solve this in proper way? That means there need to be one device is required which can track you each and every real-time data. Suppose if I give you heart medicine, for an example, any heart medicine, I'll tell you, for an example, for your simplicity, for an example, nitrocontin, there is one tablet, right? Or aspirin for one tablet, right? Suppose if I give you aspirin, maybe that will affect your kidney, right? Or if I give you one antibiotic, maybe that will affect your liver. That is the problem. I think you are very clear, right? Again, I am repeating. If I give you one antibiotic, right, amoxicillin, I think everything aware of amoxicillin, fine. If I give you amoxicillin, that may be affect your kidney, right? So how to know this? So how doctor can identify? What doctor will do is they just write based on their experience. But is it really good? Because experience, maybe sometimes experience does not work proper way. So that may be a need of proper system, right? So that may be so if one simulator will be there, they will give you some suggestion that if I give you amoxicillin to a particular patient, maybe that will affect your kidney. Because already you have kidney disease from the beginning, right? That means they can tell you that no, you can't, you should avoid this medicine for a particular patients. So how it is possible? Is it really easy? No. There may be a lot of research on that because there is no device in the world till now they have developed. No one has developed. I am telling you, believe me. Who can give you real-time tracking, right? So suppose you are giving paracetamol, what are the real-time side effects of paracetamol in graphical way? That is not possible, right? So that's why we have just started to implement this work in real-time scenario, whether and we have already that project has been already approved by Mauritius Research Council, MRIC. They have already approved our project in first pitch, and second pitch results not yet ready, but first pitch they have given a green signal, right? So what we did is that is the survey. You can see 1.55 health workers, because we are thinking about Mauritius project. That means we need to collect some data from Africa, right? So then that's why then they will be happy. So we can't say a lot of data from India as well, India, right? So that means you can see that in African countries face a severe shortage of doctors and other healthcare professionals and inadequate healthcare infrastructure. Because African country, if you consider like Mauritius, it is fine. If you consider South Africa, it is also fine. But some other countries are there; they are very dangerous, right? So that's why we need to give proper treatment or proper values to the particular patients, right? So that's why we have, this is our one of the objective. Fine. So what we did is, you can see that patient physiological data we can collect. How to collect? There may be a lot of software, maybe a lot of tests are there. We can collect physiological data. After that, we mapping target protein activity with biochemical activity. That's why we are working with biomolecular technology. I'm not telling about class 10 and 12 biology, right? There's maybe a like protein targeting protein level. So like MSc biotechnological level. Those who are from MSc biotechnology, I think they can easily understood those parts. In our body, when we face a problem, suppose now heart attack happened for an example, then what happened? Then immediately one protein will release from our body. Any damage means protein will release. That's for sure. Biological people know about this. Any damage will occur means protein will release. So in case of heart, whenever your heart attack happen or not, how doctors will know? They will give you one device. This is called TROP-T test, right? Once you do this TROP-T test, that will check your troponin level. Once your troponin level exit the threshold, that means your maybe heart attack happen, or maybe any problem in your heart, right? Accordingly, doctors will tell you that you need surgery or this, love, something like that, right? So that's why what we can do is we need to target those protein, and we apply the machine learning technique so that we can target those protein using the sensor. We can easily identify the problem, identify the target protein, and accordingly we can map with the target protein with the drug. That is means it is called protein and drug mapping or protein and drug interaction. If I give you one paracetamol tablet, that may affect your body. After some time, that may affect different organs, right? Now we can target particular protein of liver. For kidney, what type of proteins? For an example, creatinine. So that will map paracetamol molecule with creatinine, whether it is bind or not in proper way. If it is not bind, that means you are in very critical situation. So that binding affinity, that will give you one frequency, right? So that's why that problem arises. So how to bind? Because paracetamol has crystal structure. Paracetamol has very difficult structure, right? It is 3D structure. So how to bind? We need to convert those critical structure, crystal structure, to a string format, then string format to a binary format. Then we can utilize those binary format to our code. That means there is a lot of challenges are there, and already we did in our lab. Okay, so our one of my students, he is very actively working. Is Aditya. He is very happily, he's continuously is working. So together we are working on that, and obviously Shobik and other students are as well. They are working, so we can identify the biomolecular interaction, and our goal is give you real-time data in a graphical way. That's why you can see that observable features and outcome will be displayed 1, 2, 3, 4, 5, something like that. So doctor can aware of the situation, right? Fine. So you can see just for a minute. Yes. So after that, what we can do is, suppose you are in any remote area, right? And there is no network connectivity. Okay, that is also real life scenario. You are in a remote area, there is no network connectivity. Then how to send you data? So what we can do is, you can utilize your edge device in a particular moment of time, and we can process your data to the edge device. Once your mobile has sufficient 3G or 4G or 5G connectivity, at that time we can process those data to the cloud. Okay. So in the meantime, your data can be processed in the edge device. So like that way, without network also our system can work. That is the advantage of this work. Because nowadays there is a concept called zero tolerance network. Suppose suddenly if you are in a remote place, okay, there is a handshaking process, right? Or handoff technology. Suppose one cell to another cell, there is a handoff technique, right? So there may be handoff. If any failure occurs, then your data will be totally destroyed, right? Or you can't send your data because our patient is very critical. We can't stop, right? We can stop to send our patients from one place to another place. So what to do? So that's why we have a project with IIT Kharagpur with AIMS Bhubaneswar. Okay, I think everyone aware of AIMS Bhubaneswar. So we already successfully implemented in our lab at Swan Lab. Okay, I think most maximum of you know about Swan Lab. You have visited also, right? So Swan Lab, we have seen, we have more with AIMS Bhubaneswar also. Already we have solved those problems. Okay, and some of the products I will show you. Fine. So the fine. I will not tell about the this methodology part. Challenges with blood clot. You can see the scenario. Okay. So in India, one thing is very common. Not only for India, in US also, one thing is very common that we are very good in. I'm not telling about coding, right? We are very good eating something, right? So chicken, okay. So those who are vegetarian, so we are thinking you are vegetarian, right? So you are maybe not from India, right? You are maybe outside, right? So that's why you should be non-vegetarian, right? In India, and if you see that, if you start market in Agartala or suppose in Agartala anywhere, and you want to purchase some chicken or chop or aloo chop or chicken or anything, right? Automatically, a lot of people will come, a lot of customers will come easily. Your business will like 100% success, something like that. That means why we are good in fast food, right? So you can see he is very enjoying with cold drinks. So you can see cold drinks, and with this he also added in soda also with this, right? So we are in very critical scenario, right? So that's why the blood clots. So now that there is a technology how to identify the blood clots, but there is no device available. I'm telling you, believe me, there is no device available which can calculate blood clots in proper way, right? So what we can do is, you can see another scenario. He's watching in laptop and scenario. That is the scenario in real life. Okay, watching his laptop, but that chicken and a lot of other foods are available in his table, and he is totally concentrated. Okay, so that's why there is a very very difficult situation. But the real life scenario, what happened if we are continue with this, then maybe a lot of problem will arise. So our blood vessel, blood will flow in normal way, right? Just like that water pump, water pipe or something like that. For an example, after some time, if there is a concept called atherosclerosis, I think maximum of you know about atherosclerosis. There may be a fat in your blood vessel. It is very difficult to flow in a normal flow in your blood vessel, right? So then your blood can't flow in proper way. So you can see there is a blood clotting. Because there is a blood clotting, there may be interruption between atherosclerosis and your normal blood flow. Automatically blood clot happen. Now the question is, today suppose 4 blood clot, tomorrow 5 blood clots. If it is continue like that, suddenly there is a problem with brain stroke. Suddenly there is a problem with heart attack, something like that. So how to know this from beginning? Suppose today my body there is a blood clot. If I identify today, I can take medicine. Automatically that will be dissolved in proper way. But has there any device which can give you real-time blood clot? No, there is no device. I'm telling you. So we can start our research, right? So we need to prepare a device like who can real-time predict blood clot, right? So we have already started this research. Fine. So you can see that there may be a lot of other big figures I have shown you. There is a scenario like blood clot. Fine. So the studies, you see the red colored this thing, death from blood clot in America alone are approximately 300 people daily. That is the statistics. You see, which is set from WHO. Daily 300 people, you can see death from blood clot, only from blood clot. Now you can see daily 300. Then what is the value of in month, then year, then 5 years? You can imagine. So if there is a simulator or any test or something, then automatically their life will be safe. So that's why the problem arises, right? Fine. So I think there is a one common tablet I have given. Okay, I have taken permission also from one of the pharmacological company that whether we can use this medicine here or not. They can say, oh, already it is the market, right? So we can easily use those. Fine. So this tablet is called aspirin tablet, right? Everything those who are further are suffering heart attack or something, you can understood what is the objective of aspirin tablet, right? So aspirin tablet we can use when there is a blood clot or something like that. But there are a lot of side effects of aspirin tablet. You can see that the heartburn, increased bleeding tendency, nausea, upset stomach, vomiting. There may be a lot of side effects are there. And not only aspirin, if you taking paracetamol also, there are a lot of side effects. So how to solve the problem? Suppose if you have allergic patient, I can give you the drug which can increase your allergy level or histamine level, right? Histamine level, it can't increase, it should be decreased, right? So that's why we need to target particular drug with your target protein. So that's why the challenge came. Okay, how to reduce those or how to identify those problems, right? So that's why you can see that this is the structure of aspirin tablet. You can see another crystal structure. So what is the challenges here? We need to prepare those crystal structure in a what format? One string format. Then we need to utilize those in a binary code. So it is very very difficult, I'm telling you, and it should be in proper way. Otherwise, it will give you bad prediction, right? And thousands, millions life will be spoiled. So that's why it is very very dangerous because it is healthcare. And we are telling about in real time, we are thinking about two types of real time, right? Three types. One is soft, one is firm, one is dead, hard real time, right? Hard real time. That means hard real time means hard means it's life related. So you can't ignore single point. So that's why I'm telling it is very, very important to solve a structure in a proper way. That means you can't rely on the traditional data structure like binary tree, B plus tree. You can't rely on this. You need to prepare your own data structure to process those data. Okay. So how to solve this? How to prepare your own data structure? We can't use a simple optimization technique. Today you are solving and you can see that, you can tell that, yes sir, I'm optimizing your problem, but is it really fine? If I sit with them, because then my string will come up and I will sit with them, I'll tell you how many problem you have solved. They can tell you that, okay, 2 to 3 solution I have identified, but it is not optimization technique, I'm telling you. Okay, so there is a maybe trade-off, right? What is the industrial user, and then it comes to the methodology. I already told, right? So that's why there is a lot of problem arise. So that simulator already we have developed in our lab. That simulator already developed, but this is already we have filed a patent. Okay, fine. So this simulator, it is called MetaCast. So whenever we have given suppose particular drug, automatically that will give you some patient historical medical condition if you give. And if I going to, suppose for an example, my next slide, if you see my prescribed drugs, I just search in meropenem. Have you ever aware of meropenem injection? Meropenem is giving for critical patients. Suppose today I am in suppose lungs problem, okay, lungs infection problem for an example, and I am about to die. Then doctors immediately give you meropenem antibiotic, and this is very very last level of antibiotic. If your body not recovery after using meropenem, it is very difficult to solve your problem. That your life will be very dangerous. That's why I'm telling. So that's why meropenem injection is the last level of antibiotic, I'm telling. But there are a lot of other antibiotics are there. But doctors are not give those antibiotics. Why? Because you are in a critical condition. Your lungs are not good. There may be infection are there. Your WBH count certain it is 28,000. How to reduce up to less than 7% on 8,000? Okay. So how to solve this problem? So that's why doctor giving meropenem injection. But yes, that's why you have searched meropenem, right? So next slide you see. But you have kidney problem for an example, right? Existing kidney problems are there. Now the question is, I need to give you meropenem tablet, but you have kidney disease. Is it okay with you? Maybe no, maybe yes. So how to know this? Based on doctor experience. But those who are juniors then, suppose those who are junior doctor then, it is very difficult, right? So you need a proper knowledge, right? So that's why you are going to some senior doctor. Our simulator will solve each and every problem. So once you click on kidney fibrosis or fibrosis, then automatically it will give you the estimation side effects kidney fibrosis frequency for meropenem is only 0.11. That means 11%. It can give you automatic, right? Already we have developed this in our lab. So that means it will give you real-time frequency. Okay, that means I can tell you we are close to a point that I can give you one graphical structure where you are taking one medicine, it will give you this medicine has any other effects, any other organ. Suppose has there any effects or any other organs? Okay, or has there any other effects or not? That can display in a proper way in a structured format. So that's why we are already in a already we have prepared in our lab that estimated side effect kidney fibrosis frequency for meropenem is 0.11%. Believe me, there are more than 15,000, 16,000 drugs are there. What is the problem here? Because one drug, suppose paracetamol, today sir is mentioning here, well sir has mentioned, because one drug, paracetamol, has multiple brands are there. Maybe Dolo, 650, okay, maybe Calpol, maybe a lot of brands are there. But how to identify those? So like that 64 GB data are there. So we need a strong server for that. So we can't rely on the local server, something, okay? So we need a strong server. So that's why it is very difficult to process. So once we map with the particular drug, you need to map with all the brands. Then that's why that problem will be solved. Otherwise, it will not solve proper way. Something like that. So that's why there will be a lot of challenges are there. Fine. So this already patented one actually out of the box. We have work on some of the musical instruments also. So that is last but not the least, my presentation. So we have already developed with designed this with Bits Pilani, one of professor with Onil Rai from Bits Pilani. Together we have worked, and this is the first time in the world, not from India. We have developed a device which is called AI-based musical guitar. Okay, that will give you, suppose whenever you are there in the room, I am playing guitar. That means that will catch you what you need. Based on your need, that frequency will change. Okay, something. And sir is very good in like music, so he maybe understood that what is the real life problem. Maybe I am listening very well, but maybe for you it is not good. So that's why there is a problem arise. So that means you need some AI technique to solve this in proper way. Already we have developed those. This fine. So this is also in a newspaper they have highlighted. This is called Discovery of Saroj Bina, an AI-based musical marvel. Okay, already we have designed in our lab. I think it is not came in the market. My brother also working here. He's doing in PhD in Bits Pilani. He's also working here. So he's trying to because in a market we need a lot of challenges, right? We need some customization. That's why not full pleasure available, but in home or lab we have already designed. We already playing this guitar. Okay, already started trial with 400-500 something some peoples, right? So already we have started in our lab. Fine. So but last but not the least, this is the overall bibliography. So that's we have worked on. Fine. So this is the end of my presentation. So now there is a Q session. So kindly, if you have any question, please feel free to ask. Has there any question from anyone? And show up. You can just unmute so that any participants can ask from their side also, because we are not concentrate focus only here because we have large audience, right? So dear audience, if you have any questions, you can feel free to ask, because it is very important to know your feedback about this.
Okay, Dr. Joylal.
Okay, there is no question, I think, right? Okay, you have question. Okay.
Dr. Joylal.
Okay.
Are you able to hear me?
Just a second. Just a second. Just a second. Okay. Just a second. Yes.
Yeah, Dr. Joylal, you are able to hear me now. Wonderful.
Yes, I'm able to hear you, sir. Fine.
Okay, this is Dr. Rajesh Sharma from Infosys, Hyderabad. I have a question for you, sir. Yeah, I just wanted to know, like machine learning or deep learning per se, in the healthcare industry, what diseases can we investigate through the use of these technologies, and subsequently the doctor will cure them or the system will cure them. Like, I just wanted to know, like, how do you go about it?
Yes, Dr. Rajesh Verma, very nice questions. I think you are also from industry, from Infosys, which is a reputed industry. You know that, but you also know that
Yes,
for
sir.
industry point of concern that we need to focus on customization, right? So for right now, I can't tell you that a single disease which can't solve through machine learning or AI technique, because we are in a computer engineer. We need to solve each and every disease, right? So we can target. We can
Correct,
say
sir.
that
Correct.
this confidence is there. So 100% we can cover. There is no issue. Maybe not today, but in future we can easily cover. Because obviously that I will already discussed with you robotic surgery. A lot of other concepts came in the market. So easily we can utilize those concepts. There is no doubt at all.
Wonderful, sir. Okay.
Yes.
Sure. Thank you very much, sir.
Thank you, sir.
Bye, sir.
Thank you, sir. So has there any other question, dear participants? Fine. I think there is no question. Fine. Thank you. Thank you once again. Thanks to you. Fine.
Thank you, sir. Bye.
Thank you, Joanal sir, for your insightful lecture. So now we will be moving towards our lunch break, and we will resume our next session of the second day, which is that is today 5th March at 2 p.m. So I will be again sharing the Google Meet link, and we will be notifying you through the WhatsApp group to join to the link when our guests arrive at our campus. Thank you very much to all, and we will meeting you again after the lunch. Thank you.